Now we're going to try and find out the second derivative of an implicit equation. So pretty much the same as the first derivative, but you differentiate it twice. So normally to find out the first derivative, you would just differentiate this thing as normal. So your aim is to get it to dy by dx equals something, or another notation is y prime equals something. And then when you get to this stage or this stage here, what you do is you differentiate both sides again. So you would get y double prime, and then you would try and differentiate this side as well. So this side here will be blah blah blah, but then you will eventually get to have something like y prime over here. Okay, so your overall answer, when you come to differentiate it twice, you have blah 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 with y prime in the equation somewhere. So what you do is you up here, you know that y prime equals this thing here. So you would then put this thing here into this here just to tidy it up. You could just leave it as this here, with the y prime somewhere floating around somewhere in there, or you could or you know that here y prime equals this thing here. So you would then put this thing into the y prime here and then tidy up this whole thing here. You see what I mean with this example here. So to differentiate this here, to find the second derivative of this implicit equation here, you would do this here. Okay, so so here you've got one bubble, take away this bubble. Well, differentiate this whole thing here. So dy by dx, differentiate this, that will then give you this, and then here you've got to use a chain rule. So this thing gets multiplied with this thing, that will give you 6y to the power of 1 if you want, but we would leave at the power of 1, and then you've got to times dy by dx, which is y prime. Okay, and then somehow get this on its own. Okay, so starting from here, you would differentiate it, you would get this here. The thing is, you want to isolate this here, get that on its own. So add this bubble to both sides, that would give you this. Okay, and then here you've got one thing multiplying with another thing. Divide both sides by 6y. Sorry, hang on. Well, when you're here, divide both sides by 6. That will then give you this, and then here you've got one thing multiplying with another thing. You ultimately want y prime, so divide both sides by y. That will then give you this. Okay, so now you've got your y prime equals this thing here. So that's the first derivative. Okay, now the same thing here. I'm going to visualize it as y prime equals this thing here. So what we do is to find out the second derivative, we would differentiate it again. So again, I'd much rather use the product rule than the quotient rule. So visualize as this thing here. Okay, and then differentiate it again. So this is y prime. Differentiate both sides. So here you have y double prime, and then this side here. Remember, here you've got one thing multiplying another thing. You've got to use the product rule. The product rule is differentiate this, leave this the same. So differentiate this will give you this. Leave this the same will give you this here. And then on a separate occasion, leave this the same. That's this thing here, and then differentiate this. Remember, here you've got to use the chain rule. So this thing here will give you the -1, and then this power here gets minus by 1, and then you've got to times, you've got to times by the derivative of y, which is y prime here. Okay, so if you differentiate this here, it will give you this. You see what I mean about having the y prime floating around in your answer. So this is our final answer here. Y double prime equals this thing here. But then you've got this y prime floating around. You see, the downside of this notation is that sometimes you think this is y to the power of 1, but it's actually y prime. Well, anyway, this is well, up here you know y prime equals this thing here. You see y prime here. This is y prime. Earlier we worked out y prime equals this thing here. Well, we can later on we will put it into here. Okay, just to tidy up, because we don't want our answer dy by we don't want our answer y double prime equals blah 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 with the y prime in here. We want it in terms of x and y here, so we would later put that into there. Well, anyway, when you're here, visualize it like this. Okay, when you're here, visualize it like this. So you've got one block here, multiplying with another block, but then visualize this block as this, and this here is just this, and then here you've got one block, multiplying another block, multiplying this block, multiplying this block here. So this is your minus 1 here, this is your x squared here, this y to the power of minus 2, that's this block here, okay, and y prime is this thing here. So so when you're here, visualize it as this, okay, and now you know y prime. Remember, we worked out y prime earlier. Y prime is this block here, so we would then put this block into here. Okay, we will put this. Yeah, so y prime is what we worked out earlier, which is this here. So put y prime into this block here. It will then give you this. Okay, now it's just a matter of tidying up. So so you've got fraction times of a fraction. So top times top, bottom times bottom. This block here will get multiplied to the top. This one will get multiplied to the top. So it will give you this. Okay, so yeah, so yeah, this whole thing here will give you this. This block here gets multiplied to the top, giving you this. Now it's just a matter of merging the two together. So here, in order to add two fractions, you need to get the two denominators to be the same. So times top and bottom by y squared. Just so that the two denominators can be the same, and then basically merge the two fractions. So overall, y double prime equals this thing here. Okay. The thing so the thing to do here is you start out with you work out your y prime. You work out your y prime and then differentiate it again. So that will then give you this. This is your y double prime here. But remember, you've got to put what you just worked out earlier into this y prime. You've got to put this into here. So yeah, so it looks neater. But you could get away. You could just leave it like this. But we don't really want y double prime to be in terms of y prime. We would then put this into here, so it just contains x and y's. Okay.